Um, got it. We get those parts manufactured. We conform the first article. So when the manufacturer makes that first part for us, we conform it, make sure it's all good to go, the design's good to go. Sometimes we'll send that part to our customer for evaluation before they start buying it, off our catalog. And then we receive the FAA supplement. That's the document or the authorization that allows us to sell it. It makes it eligible for a certain aircraft. And that provides the authority too that the customer, your aircraft operator, like your airlines and your MROs, be able to put that part onto the aircraft. And then ultimately we sell the product. We're sort of like, we have our own website. So like, a buyer at American Airlines can go on our website, pull a part down and say, yep, ship it. I want it tomorrow. And we send it off, right? So that's what we do. We've got facilities around the world. Our main headquarters is in New York, our product development group here in Tampa, but we have distribution centers and sales offices around the world. This is a list of some of our customers, and most of your major airlines, especially our biggest footprint is in North America, but we definitely have customers around the world. And in addition to those customers, we also work with MROs, which are referred to as manufacturing repair overhaul facilities. So like if you look at those, if you're familiar with the Tampa airport, along the one side of the airport, there's all those large hangars where they do maintenance work. So some of those are MROs. They aren't necessarily the airlines personal or their own individual maintenance shops. Sometimes those are contract repair and maintenance shops. And so we provide a lot of parts to them when they're doing their maintenance on those aircraft and engines. So we do a whole breadth of product. We don't do any critical safety parts, just takes too long to get those parts to market. But everything from, bearings for landing gear to waste filters, seat cushions, things that you might find in the lavatory or the galley. We do a lot of fiber reinforced silicone rubber seals, things that clean up the airflow or create seals around, like say your doors and things like that. So a whole breadth of product. If it's going to make us money, we'll reverse engineer it and sell it. Types of roles. The nice thing about manufacturing companies is they provide an opportunity for just about every kind of job you can think of. And somebody say, like, even like doctors and nurses. Well, actually, I've worked at some manufacturers. Their facilities are so large, they have their own medical office on the facility, so that their people don't have to go off and in order to meet a medical appointment, or in the event that there's an accident or something like that, they have people there on hand that can address any kind of dangerous situation in the event that the manufacturing has some, high risk kind of work that's done. Fortunately, we don't have any of that kind of work at our facility. So we have your engineers, engineering management, the project engineers. Those are the people that are actually reverse engineering, designing, and coming up with and researching the parts that we make. They have everything from a bachelor's, master's. We even have a PhD. She's got a PhD in materials engineering. That's all part of the reverse engineering process. When we get a part, we have to cut it up and understand if it, what kind of rubber or plastic it's made of, what kind of metal, what's the granular structure of that metal, the heat treat condition, does it have a coating? So we have that materials engineer PhD on hand that we can refer to. Various kinds of engineers. We have electrical engineers. Myself, I have a bachelor's and a master's in aerospace engineering. So all kinds of, so they tend to have 4 and graduate degrees. However, my department, there isn't a single position in my department, including myself, that requires a degree. In fact, I've got a couple of my team members earn 6 figures and they have a high school education. Now, they didn't come out of high school earning those 6 figures. There was a great deal of experience and certifications other than like a college or university that they went and acquired. But it doesn't require anything more than a high school education. So those are, I have a quality manager, some quality engineers, quality technicians, quality inspectors. And so these are people that are using metrology on a regular basis. Metrology is like the study of measuring and evaluating dimensionally objects and other aspects too. And so they have everything from high school up to, BS, MS, associate's degree, certifications in quality control, metrology, some statistics. And then we have the supply chain. So those are the people, if you think about, from buying the raw material, the raw components at a forging house or metal facility or, a plastics company, bringing that into a manufacturer that's maybe machining it or molding it. And then to us, we're doing the conformity and inspection and sending out to a customer. And you think of each step as a link in a chain. That's sort of where that term comes from. And so the supply chain is made up a lot of various kinds of business people. Sometimes they're engineers that move from engineering into the supply chain because that's what they find out that really interested them. In fact, our vice president of the supply chain, he's got his bachelor's in engineering and went through a similar engineering program at GE like I did a number of years back. So you'll see that kind of movement in a manufacturing company where somebody like me, who I started out doing design work on parts for the F-18 engines, that's the F-18 fighter plane. I started out doing design work and engineering for those, and then moved into as a manufacturing quality engineer on engines for like the Blackhawks and the Apaches and other similar aircraft, but then ultimately moved into quality. And so the way my career has progressed over time is really, I just sort of made myself, I built myself up with skills such that when opportunities presented themselves, I was able to jump into those and take advantage of those opportunities. But so the supply chain, you've got people that are buyers, that are managing the purchase of components and subcomponents to make our product. The people in the warehouse that are receiving the product in and shipping the product out, and managing that whole supply chain. And so they too have a breadth of education from high school all the way up through graduate degrees in college. Things like business, operations, manufacturing operations, logistics, things of that nature. So I just want to give you maybe a quick example of what we might do on a particular day or on a project. And so, for example, something that we sell as a drag link for a thrust reverser. So this is an engine on like your one of your larger aircraft, maybe an extended range 737. So if you're familiar with the engine, sometimes they got these blocker doors that as it lands, as blocker doors slide back over the exhaust to force the thrust back forward to help slow the aircraft down. So what holds those blocker doors in place are these drag links that, so if I do a blow up this piece right here. So we had to reverse engineer that. And of course, I think I might have a video of it. Let's see here. No, I guess I didn't. Or did I switch to the video? Well, I'm just going to go back into presentation mode. I don't want to spend the time grabbing that. But we take that part, we cut it up, we analyze it, we go manufacture, get it laid out. But this is some of what you're seeing on the screen here is some of the research that when our engineers are going to they have to understand where it goes, its purpose, how it's used, what are its methods of failure, so that we can prepare for those and design against those failure modes, understand them, and so those are all the things that we look at. So with that said, I hope that sort of explained what we do at Seal Dynamics and some of the job opportunities or kind of jobs or careers that are available in a manufacturing in general, because and even more so in a typical manufacturing facility that's actually doing machining and things of that nature, they'll have a number of additional operational jobs, like the people that are actually running the mills and the lathes or the molding equipment and things of that nature too. So a whole host more kinds of positions. So with that said, do I have any questions?
You do have some questions,
All
and that
right.
was a wonderful overview. Thank you, Pete, for putting that together. From Eastlake High School, they have a couple questions. How do you make sure you're getting a consistent product every time?
So that's a great question. So some of the things that, well, one, there are tolerances on the design, right? So if a part, a widget, let's see if I can hold my. That's probably, yeah, it's not going to show my phone. If you think about your phone, right? Your phone has a length, a width, a thickness, and then on the design of that, the engineering specification, there are tolerances associated with each of those dimensions, and so depending on the design, it might be plus or minus 10 thousandths of an inch. In some cases, we work with tolerances plus or minus 2.5 thousandths of an inch. So if you think about the width or the thickness of a sheet of paper is typically about 4 thousandths of an inch. Sometimes we work in tolerances a tenth of that. So that's where you get your consistency, right? Is where if they're making the parts to the print, we're evaluating it. And so a good manufacturer too will monitor their processes. So as the parts are coming off the various equipment, they'll measure it and they'll track those measurements over a period of time over parts, and they'll develop a statistical process, and they'll be able to see what their variation is and know how to, if they need to get it under better control or if the current control is acceptable or not. I hope that answers that question.
Thank you, Pete. And a couple more questions. Does your company host internships for high school students, and how young do you hire?
So that's a great question. So here in Tampa, we're a small facility. We have between 40 and 45 people. And so for example, I just put in my budget for an intern the next year, and I typically look for somebody that's got a couple years or 1 or 2 years of post-secondary education as a background, but I'm not against looking at a high school student that has got some drive and has taken the time and the effort to learn some things that are applicable in the manufacturing environment while they're in high school.
And are you manufacturing?
Question pop up really quick. I'm sorry about how long Seal Dynamics has been around. Seal Dynamics has been in Tampa since I think 2001. I think the company was started in 75 though as a distribution company up in New York. I've been with them since 2016, so a little over 7 years.
And how did you become interested in manufacturing when you were younger? Why did you choose this as a career?
So, well, after high school, I didn't go to college after high school. I went into the Marine Corps after high school. And I was always extremely interested in aircraft and spacecraft. And so when I got out of the Marines, I went to Hillsborough Community College and started studying with an intention of going into aerospace engineering. I was fortunate enough to get a full scholarship into Boston University after graduating HCC. So highly recommend if you guys are looking at college, don't limit yourself and only look at 4-year institutions. The community colleges, especially in the state of Florida, are hidden gems. It's a great way to get a very low cost college education. So my education cost well over $1 million, and I didn't spend a dime on it. So don't let people tell you that you need to. While I was in engineering, I really that was a great choice for me because I'm one of those people when I naturally just walking down the road or doing stuff around the house, or things just naturally pop into my head. How does that work? What makes that go like that, or go underground and do this? What's protecting that? These things just naturally pop into my head. I like watching shows like How It's Made and stuff like that. So going into manufacturing just fit my passion and what I was interested in. And that's what's important, is understanding what you like to do, what interests you. So I get to come to work every day and do what I went to school for, what I'm good at, what I like to do. And so I get paid a lot of money to do what I like to do every day. It's really cool. So but it didn't come to me right away. It wasn't like I graduated high school and said, yeah, I want to be an aerospace engineer, blah, blah, blah. No, I was a knucklehead in high school, actually. And unfortunately, I could have saved myself a lot of time if I sort of figured those things out to begin with. Took 6 years in the Marine Corps to sort of straighten my butt out. But anyways, I did. So I'm doing fairly well now. But yeah, don't think you need to know everything you need to know right coming out of high school. You just do something and be productive and useful.
And we have another question from Eastlake. Are you manufacturing in-house or hiring out? And what type of software do you utilize to create your products?
I'm sorry, there were like 3 questions there. What was the?
Yep. So the first one is, are you manufacturing in-house or hiring out?
All right, so we outsource probably like 95% of our components or our product that we sell, and a lot of them to local manufacturers. So I imagine, have they had anybody else today, or they're getting any other tours today?
Yep. So we had SMT, Mastercut Tool, and TSE Industries.
So SMT is one of our suppliers actually, and we certainly, or like some of our suppliers will use some of those other companies too. You know, Mastercut Tool, a great company, by the way. Their owner's a phenomenal leader in our community. They provide cutting tools that a lot of local manufacturers use. So we do outsource the bulk of our manufacturing. However, due to growth, we recently acquired a product line, an OEM product line that now we're just ramping up. And so we're doing all that assembly work and minor manufacturing work. We expanded another 5,000 square feet to accommodate that, which was big growth for us, considering we only occupied 15,000 square feet at the time. So that was a growth of over 30% or around 30%. So yeah, most companies are constantly looking to grow. And so if they're like us, we weren't necessarily doing a lot of manufacturing in-house, but that's changing.
Great. Interesting to see your growth and innovation. And what types of software are you utilizing to create your products?
So we use SolidWorks, which is a common computer-aided design software. We also have GeoMagic that we use in coordination with VX Elements. VX Elements is the software that we use with our 3D scanner for our coordinate measuring machines, which are like a robotic inspection equipment. We use CMM Manager for that. So a lot of your CAD software though has the ability to, like, even if you're using NX or Pro E or Fusion, you can typically save a file as a step file or IGES file that then can be transferred over to a different CAD system like SolidWorks or something like that. But if you learn SolidWorks, you cannot go wrong. That's a good CAD application to learn. However, one is very much like the other. I can dabble in NX and Fusion and most of the Autodesk applications, as well as SolidWorks.
And that was a question earlier. Is it specific to SolidWorks, or will some of the other programs be sufficient? So that's good for the students to know.
Yeah.
And another question we have from from York Innovation Academy, they have a question. How long does it take typically to make an engine?
Ooh, so that question is a little more complicated than you might think. So if I have all the parts, because I've been at the assembly facilities and worked in the assembly facilities where they put an engine together, and what is it? Is it a small turbo shaft engine that's about the size of maybe one of your desks I see there in the background? Or is it a GE90, which is 12 feet in diameter and powers the Boeing 777, right? So assuming they have all the components to assemble everything, it can take anywhere, depending again on the size, from a day or two to like a week or something like that. So it depends on the size of the engine, but you think about the total time of all those components, because see, they're being made in parallel around the world, actually, all the nuts and bolts and discs and shrouds and blades and nacelle, items and blankets and things of that nature, they're all being made at the same time and then brought together at that assembly facility to be orchestrated in one big assembly event. But so, I mean, if you sort of unpacked that parallel manufacturing and you just took like the longest lead items all the way up to assembly, it's probably well over a couple of years.
Very interesting. So there's so much that goes into manufacturing. It's not a simple process. And when you learn, everything that is required to make that finished part or that finished piece, it's just astronomical to think about those things. We have another question, and this one comes from Eastlake High School. Do you work with or do you work for NASA or private space companies?
No, we're commercial aircraft. We have some military contracts, but those are parts that have eligibility on commercial aircraft that has a military application. Like sometimes, like some of the large, for example, your old DC-10s and things like that are now refuelers. Those are commercial aircraft, and they use the same parts on the military ones. So where we have that crossover, that's where we have those military contracts. But we don't work with NASA or private space companies. Those tend to be those companies. There are, in fact, when you guys see SMT does job work for companies that outsource their work to SMT to make parts for like satellites and spacecraft and things of that nature. It's just not in our wheelhouse. It's not that we can't do it. It's just not part of our business model.
And so, yes, manufacturing companies like to stay focused and, really develop a specialty, and then, take that and move forward with it. So on that note, is there anything new and up and coming for your company? I know you just had a recent expansion, but as far as any new technologies that you're looking into or anything new that's down the, in the pipeline for Seal Dynamics?
So from a new standpoint, we're always looking at new ways to make the reverse engineering process quicker. So, like a few years back, we purchased a 3D laser scanner that's handheld, so we can take it to a customer with us and scan parts like on the aircraft. That was something that they never did before. And different ways for metrology. So we constantly look at ways to improve our inspection and reverse engineering process overall. We recently just purchased an additional 3D printer through the Ultimate 3D Printing Store right there in Odessa. I know Roy Kirshner was featured on Fox 13 this morning at AmSkills. So that it's not necessarily new product because we're reverse engineering current product. So as your Boeings and your Airbuses, your GEs, your Pratts and Rolls-Royce, as they're coming out with new product, we're going to reverse engineer those things. And so we're really coming up and trying to invest in new technologies that help us in what we do in-house, the reverse engineering and manufacturing qualification. I do see a question. What are some entry-level jobs and starting pay? So it depends on I have taken on some entry-level inspecting positions. I think our entry level is around 18, 19 for an inspector. I'm sorry. The warehouse might be a little less. Those are something that doesn't literally they can basically take somebody straight out of high school for the warehouse. And then for my inspector positions, that's a big range too. They might start at 18, 19, but they quickly ramp up. And I've got people that, like I said, I've got people in the quality department that are earning just under 6 or over 6 figures. The engineers tend to be, like I said, those are people that are coming out of college and they command a much higher wage starting with that 4-year engineering degree. And that's one of the reasons why a lot of people seek engineering degrees. It's extremely difficult and challenging school, but they're paid quite well coming straight out of school.
what are some of the things you look for in new hires?
So, the two main things for me are attitude and aptitude. You're spending a large part of your life, your waking day, moments out of a day with a group of people that you at work, and so it's important that you fit into that team, that you work well with that team and engage that team, because it's like almost like an extension of your family, and so it's really important for me to have the right attitude. That's going to work in that environment. And then, of course, aptitude. If there's things that we need you to know or learn or be able to do, but you don't necessarily know them at the time, we can train you. But you have to have that ability to learn that stuff. That's where aptitude comes in.
And did we talk about the youngest that you hire?
So I think the youngest that we've hired is probably I want to say early 20s, and it's not to say that we won't go like into teens right out of high school. It's just that we haven't been presented that opportunity, I guess.
And that's good to know. And if someone is interested in a position or learning more about your company, how would they find that information, Pete?
So if you go to hyco.com, and then on the top right, there's like careers, and you go and click on that. You can search jobs that are in HICO to include Seal Dynamics that are available, and you can even plug in the zip code and give you jobs in a particular area. Or like maybe you want to go work in a different part of the country, you can go plug in a zip code or city somewhere else and see what's available too. And a lot of companies have that kind of link on their websites.
Okay, we'll make sure that we put that information in chat so that our schools and our students can go and learn more about you and how to apply. We'd like to thank Eastlake High School for being here. They have to drop off, but they will be back later. But we still have a few schools with us, I believe. So if you have questions, don't forget, you can take yourself off of mute, ask those questions directly, or type the questions in the chat box, and we will be happy to answer any questions that you have, or Pete will be happy to answer any questions you have. We were talking a little bit about, you were mentioning now you have the scanner that you can scan a product for reverse engineering, and then that can be 3D printed. As far as taking that scanner and being able to take that to your customer, how much time do you imagine that is saving your company, or time and money, that's saving because of that technology?
So first of all, what we can do with the 3D scanner with regards to dimensional analysis, we can get in an hour, half an hour, what might have taken 40 hours worth of metrology work previously. Also, the ability to go, sometimes these components that reverse engineering, we did this one item at the supplier where it's like 15 grand a pop. So to be able to just go and buy several of those to reverse engineer, it doesn't make sense. And so the ability to go to the customer, scan the part on wing, so to speak, is extremely valuable. Not only that, though, if we can scan the next higher level assembly, what it's actually being assembled to, that gives us a great deal more insight into the design of that part and how it functions, and allows us or provides us the opportunity to design a much better part for our customer and better serve our customer.
Okay, thank you for that, Pete. We have some more questions that have come in, and this is from Dunedin. Does your company have knowledge of the longevity of insured operating ability of engineered products? And are there warranties for purchasers?
Yes, there are warranties. So let me start with that. Yeah. So just like anything that you guys might buy, we do offer warranties. We don't often have to execute on those. That's part of my job running quality, right? Now, so because we're not the OEMs of our parts, we're not privy to the environment, the operating environment. So that's not something that we are particularly researching, because that's already been done and we're just duplicating that component. Now, if we were the OEM, and I know this because I used to work at, like, say, GE Aviation, there's a whole department that was dedicated to determining the life of a part, right? And so during that whole design development process, they would know, all right, so this is going to be on this kind of engine, that's going to go on this kind of aircraft, that's going to be operating these kinds of routes. What's that route look like, right? Or cycle. And then they would determine how many cycles that part could go through, right? And that's often that kind of research and analysis is what's performed in order to come up with the maintenance manuals. And so all those operators and MROs, they know that, hey, look, after so many cycles of this engine has to come off wing to get certain parts replaced, or that forces them to go and look at certain components on the engine or the aircraft. Hey, we know after so many landings that we have to take a look at these brake pads or something like that. And so there are whole groups of engineers or people that are performing those kinds of analysis to come up with those life predictions. And then us too, not just the OEMs, but us as well, as since we're providing these same components, we have continued operational safety. It's a whole process program that companies like us and the OEMs too have to have, and to get audited and monitored by the FAA to make sure that we're monitoring that life, the life after we sell it. It's continued operation out in the real world, and making sure that they're living up to the standards that they're supposed to be.
Great question. That was
Yes.
a great question, Dunedin. And Pete, as far as industry trends, we talked about, you started with the scanner. How do you keep up with industry trends that are out there?
So, for example, IMTS, it's the manufacturing trade show in Chicago. It's every 2 years. It's the largest trade show of its kind in the Western Hemisphere. It occupies the entire Chicago Convention Center. So take the Tampa Convention Center, multiply that by 4, and fill it with manufacturing technologies, whether it's machining and 3D printing and metrology and just you name it, things that support all that stuff. So all the environmental health and safety stuff, the support platforms, all that. So I attend those shows, as well as organizations like BAMA, Bay Area Manufacturers Association, Florida Advanced Technological Education. They help link manufacturers to these kinds of technologies, or at least the people and companies that are coming up with these new technologies and thinking these ways. And so we stay in contact with the people in our community, in our industry, to make sure that we understand what's constantly coming out. So I'm attending those shows. Measurement Supply, for example, had a sort of a trade show this week, a big Oktoberfest, where they had all these metrology companies in there, some manufacturing, to show and showcase their new technologies. And so that's one way that we keep on top of that stuff. And then just constant, I get magazines and periodicals and things like that I read constantly to make sure that, hey, I'm paying attention to what's new and what's coming out.
So being at one of those shows, what is the coolest thing that kind of blew your mind that you've seen at a trade show? Is there anything that really stands out?
Oh, so 3D printing is just leaps and bounds is improving. So there's different kinds of 3D printing, but the one I saw at the trade show was they were 3D printing the headers for a car engine, which out of steel. So 3D printing steel, and so both the platform holding the workpiece and the print head were all on 5 axes. So they never had, so it was constantly turning the workpiece so that the material was always getting put, relative to gravity. So they never needed support material, which was just absolutely incredible. And being able to 3D print those exotic metals too, like Inconel and titanium, things of that nature.
Very cool. And you mentioned a little bit about the Bay Area Manufacturers Association. We've talked about it a little bit today. with some of the classes. I'm with the Bay Area Manufacturers Association as well, and we are a industry-focused, membership-based association here in Tampa Bay. We've been here for 62 years, and we do a lot of things to give back to the community. Pete is on our board of directors. So, Pete, do you want to talk a little bit about your role on the board and the Workforce Development Committee and some of the things that the committee does and some ways for the schools to get involved with the association?
So as part of the Workforce Development Committee, we do our best to link manufacturers or industry professionals with the schools. So although October is Manufacturing Month, that's really just a month we're sort of focused on it. But we do tours and guest speaking throughout the year. And so I think for all the educators that are online, if you are going over you're going over a certain topic or subject or something like that, and you really like an industry professional, either in person or virtually, to come and maybe amend or supplement, help you teach that class, or even just come in and speak on what they do that's associated with whatever you're teaching, please reach out to us. We love to do that kind of stuff. We love to connect you to those people, and because it helps raise awareness of our industry and the opportunities for young people coming out of high school. So please definitely reach out to us. We love doing that kind of stuff. We love getting to know you guys and supporting your educational efforts.
Yes, thank you, Pete. And Pete is extremely active in giving back. So thank you for that, Pete, not only for being here today, but everything that you do all year long for the students and for manufacturing. Big advocate. So we were very happy to have you. So thank you so much.
Thank you.
Do we have more questions coming in? You have Pete now, you have his attention. So now's the time to take advantage and ask those questions that you've always wanted to know about manufacturing. There's no question that is out of the realm, as long as it's focused on the company, manufacturing. We want to hear what you're interested in and what you have to say and what you want to learn. As far as, one of your first slides, Pete, you showed all the different companies that you're working with. How does Seal Dynamics stand out? How do you get in touch with those companies to work with them? Do you have marketing efforts that you use to promote your company? How do you go about those types of things?
Yeah, absolutely. So for example, there are trade shows by those companies, right? So I don't know if anybody online has ever heard on the news, like the Paris Air Show and stuff like that. They call it the Paris Air Show, sometimes it's held in the UK. It's an air show, yeah, but it's really a big air show. It's really a big sales show for like all your Boeings and your Airbuses and stuff like that. So HEICO, the company that owns Seal Dynamics, and Seal Dynamics will have huge booths. Literally, I've seen the marketing booths that they have. They're like as big as a house, and they have all their salespeople there. So next week is the MRO in Amsterdam. That's their maintenance, repair, overhaul trade show in Amsterdam. And again, that's huge. HEICO, our parent company, Seal Dynamics, will have a huge booth and presence there. And that's where they're going, and they're maintaining those relationships. But we have salespeople that are at Delta in Atlanta, that are at American Airlines or Lufthansa. They're at those facilities, their main hubs, and constantly working with those customers to make sure that, hey, look, because we're making and designing new parts, anywhere from 50 to 100 a year, because every time a new platform comes out, a new aircraft, that means older ones are being retired, right? So parts that we're selling that can go on like the 737-200, well, no U.S. North American operators operating that aircraft anymore. Maybe they are in Southeast Asia or South America, but nowhere in North America. So as older fleets get retired, we're going to lose the sales on all those parts. So we need to constantly be designing new parts that are new parts for us that are on newer aircraft. And so we have to constantly be engaging those customers that are purchasing those new aircraft so that we can get access to those parts and understand the ones that they want to purchase from us.
Makes a lot of sense. We'd like to welcome Countryside High back. Pete, I don't know if you have the time to maybe do a little brief recap from the beginning for Countryside that's just joining us.
Sure.
Maybe go back and into your presentation to talk a little bit more from the beginning of who you are and your company so that we can catch them up.
Yeah, give me just a second here too. I want to see if I can find that video real quick. But in the meantime, I will.
And we'll give you a minute if you need to find the video. We can wait. And we will be here until about 1 o'clock, 1:15 today, all day long with different manufacturers. This morning, we talked to Southern Manufacturing Technologies, Mastercut Tool, and TSE. We have Monin coming up later this afternoon and Amrock. So we've got a lot of exciting things still in store on this manufacturing day. And don't forget, if you have not been able to view all of the videos, the links will be still available to you. You can use the link that's been provided and watch those videos on demand at any time.
All right. Well, I had it a second ago. Okay, I got it, I think. All right, so I'm going to share the presentation here real quick. Okay. Oops. All right. So again, I'm Pete Cirak, Vice President of Quality at Seal Dynamics. We're an aftermarket commercial aircraft parts provider. And so what we do is we work with our customers, the airlines and MROs. It's maintenance, repair, overhaul facilities. So like we work with your Deltas, your Lufthansas, your Cathays, your Emirates, and so forth like that. And we identify opportunities. So wherever there's maybe there's a part on the aircraft that, they purchase from Boeing or Goodrich, and they're being charged a great deal of money. And if it's something in our wheelhouse that we do well, and the sales are there, we'll take it on. We'll reverse engineer it, get that approval to reverse engineer it through the FAA. We manufacture the parts. Sometimes for the bulk of our parts, we outsource the manufacturing of those parts. We bring in the parts, we conform them, we inspect them, validate their design, make sure that they meet the design criteria. And then we receive the supplement. That's like the authorization from the FAA that our part can be used on that particular aircraft or that particular engine. And then once we have that allows us to sell it to a customer, and that customer is able to put it on that aircraft or that engine. And then ultimately we go into full-scale production on it then and sell the product. We have offices around the world. Our main distribution facility, actually, you can see is my background. The warehouse behind me is in New York, Long Island. And then our research development facility is here in Tampa, where I work. But we have sales offices and distribution facilities around the world. We work with numerous customers and airlines, MROs. As you can see, our largest footprint is in North America. That's what works well for us. But we certainly engage and try to grow every single market. We do a breadth of product. We don't do any critical safety parts. We do everything from a split ball bearing in the landing gear of a 737 to a toilet seat, to the latch that holds up your tray table, to a seat cushion, to filters you might find in the lavatory or galley. We do a lot of fabric reinforced silicone rubber seals that create air seals around parts of the wing or access a door, doors and windows and so forth like that. So just to give you an idea of some of the roles, we have a whole engineering group, and their education is rightfully so, is typically a bachelor's in engineering or higher. Myself, I have a bachelor's and a master's in aerospace engineering. But it's all kinds of engineering. It isn't just like aerospace. We have mechanical engineers, electrical engineers. We have a materials engineer that has a PhD because we have to, during the reverse engineering process, we have to, cut those parts up and understand what they're made of. Do they have a coating, or what kind of shot peen, what kind of heat treatment are they in? And so, we have engineers that come straight out of college that have, 2 decades of experience. So it depends. The quality department, which I run, now there's no role that requires, we have people that have degrees, but no role that requires a degree. And nothing more. The only education that we require in my department is a high school education. A lot of people have post secondary education through certifications and stuff like that, but it isn't necessarily a requirement. In fact, I've hired some people that had 0 experience in metrology, and we've trained them over time. But we a whole host of positions, from quality manager, engineers, technicians, inspectors, document control, and they have backgrounds in quality control, metrology, and statistics typically. Supply chain. So if you think about, from the purchase of the raw material at the the house that melts the metal and so forth like that, to the casting company, to the company that takes that casting, machines it, to then it comes to us as a machine finished component. We verify it, and then sell it to our customer, who ultimately gets it, puts it on the aircraft. If you think about each of those steps as links in a chain, that's where that term comes from, the supply chain. So those people, again, they have a gamut of educational backgrounds, from high school all the way up to graduate school. They typically tend to have focuses in business or manufacturing operations and logistics. But for example, our supply chain, the VP of supply chain has a similar background to myself. He's got a mechanical engineering degree. And so he just, like me, I started out in design engineering and moved over to manufacturing quality. And like him, he started out in design engineering and went over to the supply chain side of the house. So sometimes you'll start in one particular part of a manufacturing company or an industry, and then realize that you like a particular aspect or part of the industry that you do well in, right? And so that's sort of how my career progressed. And he's a different example of how somebody started out doing design work or doing one thing and then migrated and evolved into something else entirely, and is very successful. So I wanted to give you a quick example of like sort of what we do, that reverse engineering process. So you take a large jet engine like this that you might see on the larger long range, like 737 or 757. So the engine has these doors that go back or fall back over the thrust, and they're called thrust reversers. So they redirect the thrust coming out of the back of the engine to go forward to help slow the aircraft down. So as those doors fly back, there's these items, these bars essentially, that are holding them in place. So we take something like that. Our customer comes, it says, "Hey, look, can you sell this to us instead of GE or Goodrich or somebody?" And so we reverse engineer it and have it manufactured. And so I have a little video here. I think I can show you. I'm going to unshare this and try to share this video. Got to pull it up here. Wait a second. Let me share it. There we go. All right, you seen the video? Sound isn't important for this, but that's our coordinate measure machine. This is the link itself. So our coordinate measuring machine is a robotic piece of equipment that, as it goes around, that little style, that's a ruby tip on the end. As it goes around and touches the part, it's creating a three-dimensional image of that part. These other things right here are just stands. Those aren't the parts. It's just something that we have it sitting on. These are actually designed by our team and 3D printed in-house. So scan over here to the, or it's about to look over. So that's the software. So as again, like I said, as it goes around, it's developing a three-dimensional image of that part. You can see, you guys know your Cartesian coordinate system, maybe X, Y, Z's. So it's effectively dimensionally inspecting, evaluating this part to make sure it meets all the design criteria. And this machine, our coordinate measure machine, is fully robotic, 5-axis freedom. You can see the head just articulated around. So one of our team members wrote the program so they can put this part on the CMM on this fixture, hit go on the program, come back a half hour later and the inspection is done. And so that's something that people on our team have learned how to do. And again, that's somebody that only had a high school education. We're able to send them to school or even learn on the job in-house on how to write these programs. Oops, let me go back to stop sharing. So with that said, I hope there's some questions. I'm sorry, I got a phone ringing in the background. One second.
And go ahead and put any questions you have in the chat, or just take your mic off of mute and ask your question directly. Pete, you were showing how you had a fixture that was 3D printed. What else do you use your 3D printer for? Do you use it for any tooling or any tools, or what else do you use the 3D printer for?
So that's great. So we actually just purchased a new 3D printer through Roy Kirchner's Ultimate 3D printing store up in Odessa, actually. It's a multi-head 3D printer too, so we can print in a host of different materials, one of which I'm excited. We haven't done it yet. We're about to do some carbon reinforced nylon. So we use our 3D printer. We now have two. We use them for things just like you saw in that video, like support fixtures. So we have a laser engraver, for example, a laser marker. And so to be able to set up programs, it's important to be able to put a part in the exact same place every time. And so when you design a fixture, I can go have that fixture made at a machine shop out of metal, and it costs me a few $100s, or I can 3D print it in a few hours, for just a couple of dollars worth of plastic. So it depends on the application, but we typically use it for tooling and fixturing, and in some rare cases, for some gauging.
Okay, that's great to know. And you were showing, you were talking about the quality department. So what measurements do you have in place to maintain the highest standards of quality in your products?
Oh, well, it comes down to, training experience for one. I have inspectors, some inspectors that have basically I think my lead technician's has about 35 years of experience in manufacturing, and a bulk of that in quality. I've been in aerospace now for 20 plus years. I think between my three lead inspectors, probably over a century's worth of experience. But we do have some younger ones, but they have those more experienced inspectors to rely on as mentors and trainers and so forth like that. So we do a lot of training, both formal and informal, both in-house and outside. We have some very expensive equipment. For example, that coordinate measure machine is a large capital expenditure on our part. We have a bunch more various kinds of equipment that are able to inspect to those very tight tolerances. Especially a piece of equipment, metrology equipment has to have an accuracy at least a tenth of what the tolerance is. So if you're inspecting something that is plus or minus 1/1000th of an inch, the accuracy of that measurement equipment has to be plus or minus 10/1000th of an inch. So it's important to have the appropriate measurement equipment in order to check the things that you need to check. But and not just dimensionally, we have force gauges and light gauges and various other kinds of equipment to analyze the appropriate design criteria.
And how do you handle unexpected challenges or issues in quality?
So in life, in general, what separates one person from another is the ability to handle the unexpected. Let me just tell you that right now. All right. So I don't get paid to handle the ordinary everyday stuff. I get paid well to handle the things that aren't understood or aren't expected. And so it's about being nimble. It's about being, my boss and I often say, especially like when we're dealing with an upcoming hurricane or something like that, luck favors the prepared. So part of what we do on a regular basis is we try to think about what can go wrong, right? And even and when we're reverse engineering parts, hey, how can this thing failure on the aircraft or on the engine, right? So that we can be prepared for it, so that we can set up our quality plans to check for those things ahead of time. So that's a large part of, in every part of our business. Hey, what happens if we lose power? How are we going to continue to ship parts? How are we going to continue to do business if this happens or that happens? What can we do to mitigate those risks? That's a large part of what any company's leadership is constantly doing on a day-to-day basis.
It's always good to be prepared, stay prepared.
Yeah.
Stay ready. And as I ask that question, my dog just starts barking. So right on cue. And classes out there, if you're still with us, we hope you're still with us. Let us know that you're still listening, still with us today, and what questions you have for Pete. If you have any questions about jobs that are available, a little bit more about what his company does, feel free to take yourself off of mute, ask those questions, or ask them in the chat box so that we can get your questions answered. And make sure that you're finding out as much as you can about Seal Dynamics. And thank you, Countryside, for letting us know you're still there. Pete, and maybe talk about a little bit about, we were talking earlier about what you look for employees coming in, what advice you have for students at this stage of their life, how they should be preparing themselves for a career, not only, in school, but, outside of school, how can they be getting ready for a great career?
So if you can find a way to get associated with a professional or industry organization like the Bay Area Manufacturers Association, right? I don't think, correct me if I'm wrong, Beth, but we don't have an age requirement to be a member of BAMA.
Not at
and
all.
So there's nothing stopping you as a young adult, a high school student, from attending BAMA events and meeting manufacturers. A bulk of the people that attend our events are the CEOs and presidents, the owners of these manufacturing companies, the hiring managers at these companies. And so if you're not attending these kinds of organizations or getting involved with them, like with your IEEEs, your AIAAs, your SMEs, your ASMEs, you should be getting involved. Find out which industry professional organizations that are active in this area that are centered, or their objective is around what you are interested in and like to do, and get involved with those. Become a student member. A lot of times those organizations will have student membership values, because a lot of in order to become a member, you have to pay some sort of membership fee, and sometimes that could be a few $100s for a professional. But as a student, a lot of times they'll have a student membership fee, which is a lot lower or smaller. When I was in college, I was a member. We had a local chapter for the American Institute of Aeronautics and Astronautics, which I'm now, as I was a student member when I was in college, and now I'm a professional member of, and have been for a whole number of years. So the 20 plus years I've been in aerospace. I'm also a member of AOPA, the Aircraft Owners and Pilots Association, a member of BAMA. So get involved and engaged in those organizations. That is a great way to begin to build your network, your contacts. And I hate when people say, "Oh, I want to go into a networking event." Networking is something that you do once in a while. It's really more like a philosophy. It's something that you're constantly doing. Your best networkers are networking even when they go to something that has nothing to do with their job. If they're going to a dinner party and they meet somebody that's just even slightly associated with their industry, they're making a contact, right? Hey, and developing that relationship. So it's really something that you do constantly. And like I had said earlier online, that prepare yourself so that both skill wise and network wise, so that when an opportunity does arise, you're in a position to take advantage of it.
Good advice, very good advice. And it's good to think about getting a mentor or someone that is in the place that you want to be. So if you are interested in a career, reach out to someone that's doing that, or doing what you want to do, and it's the best way to learn. And most times they're very happy to guide you and to meet with you. So don't be afraid to reach out. Most of our manufacturers are very willing to share their knowledge, and they really enjoy that. So always feel free to reach out. As Pete was saying, with BAMA, we do have a lot of informational type events. We have one coming up in a couple weeks. It's on the 19th. It's an Industry 4.0 roundtable. And so that's a great way to, we have different presenters on different topics and the different areas of Industry 4.0. And it's a great way to learn about those different emerging technologies, as well as meeting your local manufacturers and being able to talk to those manufacturers directly. So we do always welcome, if you're a teacher or if you're a student and you'd like to attend, information is on our website, and we'll put our website in the chat as well. Become familiar with BAMA and the things that we're offering, and all of that will help you once you're ready to begin your career. It just really prepares you. And so we're always happy to do that and to reach out to Pete or I anytime as you're going forth. But Pete, talking about your career, what valuable lessons have you learned throughout your career in manufacturing that you'd like to share? And what are some things, just what have you learned, or what challenges have you faced that you've overcome?
So I think, the interesting thing about manufacturing, and it's so in the state as well as nationwide, is that approximately 75% of manufacturers have less than 25 employees. So think about that. So a lot of times when people think of manufacturing, they're thinking about that Lockheed Martin that has 500 employees up the street, or Mettler Toledo that has several hundred. That is the unusual. The usual are the mom and pop machine shops. If you meet Southern Manufacturing Technologies later, who's owned by Roy Sweatman. He probably doesn't want to be referred to as Pop, but he's a great community leader. But again, he started out with just a handful of people, and that's 75% of the manufacturers. So think about that for a moment. That means that owner or his top leadership, they're wearing a lot of different hats. That owner might be the CFO, the HR, right? And so you go and work at a company like that, and they ask you to do something that maybe isn't part of your normal day-to-day stuff, and you're like, hey, that's not my job. Well, you know what? You're probably not going to have a job for that much longer, right? Because at a company like that, they need people to be nimble, to be passionate about learning new stuff, and quite frankly, take on that thing that isn't part of their job description. And that's what makes those small companies successful and, quite frankly, awesome to work at too. One of the great things about my job is I get to do different stuff all day long, and throughout the week. I don't have, people ask me, what's your typical day? Thank the Lord, I don't have a typical day, because that would drive me freaking insane. Now, there are people that like that. There are people that are geared that way. And you know what? There are companies that you can go and find that job where you go and put widget A into widget B all day long. Hey, and that there are people that are geared and need to do that kind of stuff. It's not me. And that's one of the things you need to sort of figure out, what you like to do. And that will help guide you on what kind of company, what kind of job you need to go and find too. But for me, to answer your question, Beth, that's sort of what I learned, is that what makes people, and at least in my observation, successful are those people that are willing to go and stretch outside of their job role to get the things done, to address the unknown when they happen, and to resolve those problems.
Thank you, Pete. And we're getting ready for our next organization. But Pete, do you have any final words for the students?
Hey, just listen to your teachers. They got they're thinking about you guys and want the best for you guys. So, and then there's a whole host of us out here that love to support them. So, keep doing what you're doing.
Thank you so much. We appreciate Pete's time. Everyone, let's thank Pete for being with us today from Seal Dynamics. Good job, Pete. We appreciate it. Thank you so much and for everything that you do.
Thank you.